right, folks, so yesterday you learned about the general principles of density. Today we're going to work with some of the density calculations. So bust out that calculator, that phonulator, probably some scrap sheet of paper to do your work on. That's what we're doing. Now, a few things before we actually get to problems. Let's make sure we remember our equations. So the volume of a cube, we didn't talk about this yesterday, but this is something that will be relevant because density involves volume, or density calculations involve volume all the time. And just so you know, the volume of a cube, any given cube, will be the length times the width times the height. So just make sure you keep that in mind. I'm sure you have seen that equation in like geometry or something like that before. The density equation, of course, is mass in grams over volume. Volume will be one of two units, which we'll talk about here in a second. The units for mass are grams. The units for volume are centimeters cubed, and that's for a solid, or milliliters, and that's for a liquid. Okay? And so that means that density, since it's mass over volume, will either be in grams per milliliter or grams per centimeter cubed. Especially as we're first starting out, I'll be a little bit of a stickler for these units, so make sure you're paying careful attention to what units you're working with. It's really centimeters cubed when you're talking about solids, milliliters when we're talking about liquids. Yeah. Okay, so you're going to complete the following problems. Be sure to show your work. The proper units must be included in your final answers. No work equals no credit, blah, blah, blah. And don't forget significant figures. Okay? Make sure all your answers have proper sig figs. We're going to do 3 problems here today, and then I'll let you guys take care of the rest on your own. Okay, so first problem. What is the density of a chunk of cement that has a mass of 8.76 grams and a volume of 3.07 centimeters cubed? Okay, so the 3 variables we have are density, mass, and volume. Looks like density is what the problem is asking us for. So we have mass, 8.76 grams. We have volume, 3.07 centimeters cubed. So if I plug that into my density equation, okay, density equals mass over volume. So that's going to look like an 8.76 over 3.07 centimeters cubed. My calculator will tell me 2.8534. But because we have 3 sig figs divided by 3 sig figs, okay, that means we can only keep 3 sig figs in our answer. So 2.85, and we round after that 5. So that means our final answer is just going to be a 2.85. And our units will be grams per centimeters cubed. This is the density, so you need grams over volume, or mass over volume. And this is a solid, so it's going to be centimeters cubed for your volume, not milliliters. All right, you nerds. Let's talk about the next one. Should be a little trickier. The reported density value of silicon metal is 2.33 grams per centimeters cubed. What is the volume of a silicon block that has a mass of 62.9 grams? Okay, so we're switching things up a little bit. So density we're given this time, unlike last problem, 2.33 grams per centimeters cubed. Mass, we're also told, is 62.9 grams, and the volume is what we don't know. So before we even do our math, we're going to have to rearrange this equation a little bit. So we do start off with density equals mass over volume. But we're trying to solve for V, so we need to get volume by itself. So here's what you can do. To rearrange this, if you multiply both sides by volume, okay, so you'll see your volumes cancel out here. So that tells us that volume times density is equal to mass. And then we have to rearrange this one more time. So again, after that first step, we're sitting here with volume times density equals mass. But we need to get volume by itself. So if we divide both sides by density, density cancels out over here on the left. And so we'll find that volume is equal to mass over density. So you see, I rearranged the equation before I actually plugged in any numbers and did any math. Okay, so volume equals mass over density. So now I can plug things in. So that's going to give me 62.9 over 2.33. So my calculator tells me 26.996. Again, remember, 3 sig figs divided by 3 sig figs. I'm allowed to keep 3 sig figs. So 26.996, you round after that first 9. So this is where you're rounding after. Here's your line. So that means that, okay, so this 9 tells that 9 to round up. So this 9 will become a 0. That will make this 6 become a 7. And so we're left with a final answer of 27.0. And yes, you do need to have that 0.0. You have to keep exactly 3 sig figs. So this 0 right here, this isn't something that is random. We're pretty sure that's a 0. It's our estimated value here. And so the units on that, well, it is a volume. And what kind of volume are we talking about? Well, we're talking about a solid volume, talking about centimeters cubed. So 27.0 centimeters cubed. Now let's try the last one. This one's a little bit trickier than the others. Okay, so we have a block of copper metal that has a mass of 1,896 grams. The dimensions of the block are 8.4 centimeters by 5.5 centimeters by 4.6 centimeters. From this data, what is the density of the copper? Hint, find the volume of the block first. So this problem's a little bit different. So we're asked for density again. We're given the mass, but we don't know what the volume is yet. We're not even given the volume. And so we're going to have to calculate what that volume is first before we can move on to calculating the density. So as we recall, the volume is equal to length times the width times the height. In this case, that's going to be 8.4 times 5.5 times 4.6. And if you plug those in, you'll get 212.5. Okay, 212.5. But let's remember that this value right here can have how many sig figs? Let's see here. We've got 2 here. We've got 2 there. We have 2 here. So this value can only keep 2 sig figs. So 212.5, you need to round after the 1. So that 1 will round, or that after that 1, you'll get 210. Okay, so that's why when I plug this in, my volume will be 210. 210, and notice it's centimeters cubed. And that kind of makes sense because we have 8.4 centimeters times 5.5 centimeters times 4.6 centimeters. Centimeters times centimeters times centimeters equals centimeters cubed. So if I want to find my density, I'll take my mass, 1,896 over 210. I'll get 9.0286. But please remember, I can only keep 2 sig figs because I have 4 sig figs and 1,896, but 210 only has 2. So I can only keep 2 sig figs. So that's going to be 9.0, 9.0. And the units on that will be grams per centimeters cubed. So I want you guys to go ahead and do the rest of this worksheet during the day today. Please note that number 5 has some tricky sig figs as well. So just make sure you're writing your steps out. You're taking good care to be really organized. You're paying attention to your units. You're paying attention to your sig figs. And you should be in business. So why don't you guys go ahead and get this puppy cooking for the rest of the day. I'll see you in class tomorrow if you're cohort B, or live in class tomorrow if you're cohort A.